The F-35 Lightning II is, perhaps, the most widely criticised military program in modern history. Plagued with early difficulties and delivered several years late, the Lightning has been savaged by the popular media and the online community. A child of the social media generation, and called a turkey, boondoggle, and trillion-dollar fighter by critics such as Pierre Sprey, the F-35 is probably the most misunderstood fighter in history. The cliché, can't turn, can't climb, can't run, probably sums up this fighter to many people. The ugly duckling that just doesn't appear to be an improvement over previous generation systems in the elements of air combat people most intuitively understand: speed, or kinematics, and maneuverability. But to really understand the F-35, you need to, after wading through all the disinformation, look beyond the basic statistics listed on Wikipedia. The thing many people don't understand about the nature of air combat, and therefore what the F-35 is designed to achieve, is that we no longer live in the Vietnam era, and the nature of aerial battle simply isn't what it once was. The F-35 was the product of the Joint Strike Fighter program, which was begun in 1996. The original goals of the program were to produce a replacement for several aircraft which had similar roles in different services, primarily the USAF's F-16s and the Navy and Marine Corps' FA-18 Hornet. Additionally, the USMC was looking for a far more capable replacement for its AV-8B Harriers, one that was still capable of short takeoff and vertical landings, or STOVL. Given how similar the three services' requirements were, the decision was made to amalgamate several replacement programs into one joint fighter. The resulting Joint Strike Fighter program would produce three variants, one for each service, which would be as common as possible, sharing avionics, weapons, engines, and much of the airframe. After a long competition between Boeing's X-32 and Lockheed Martin's X-35, the later was selected and the F-35 program was born. However, with a fighter as complicated as the F-35, which had to meet the demands of three services, the early development phase was problematic. The STOVL variant specifically was having substantial weight issues, causing delays to the program as a whole. Although the first production F-35A flew in 2006, the system demonstration and development phase was still encountering several issues, and by 2009, it became apparent that additional time would be required, some 30 months in total. These delays pushed back the initial operational capability, or IOC, by around 3 years, with the naval variant finally achieving squadron service in 2019. Because of the high level of concurrency, a term which means that aircraft production had begun whilst the testing program was still ongoing, the number of faults that were revealed required a large number of changes to production aircraft. These processes caused additional costs. All told, between 2001 and 2010, the F-35 program was running around 6 years late and $13 billion over budget. However, in February 2010, the Pentagon restructured the program, largely bringing these cost and timeline overruns under control. Although the F-35 cost and production rate is now going quite well, it has never really lived down the reputation it earned as a troubled program through its early trials and tribulations. The Joint Strike Fighter program gave birth to 3 F-35 variants. The first is the F-35A, which is the direct replacement for the F-16 and is optimized for use in land bases. It is 15 meters long, has a wingspan of 10 meters, and an empty weight of 29,000 pounds. The F-35A is the cheapest, lightest, and most capable variant, with a 9G limit and 590 nautical mile combat radius. This variant also has the best thrust-to-weight ratio. The STOVL variant is the F-35B. The F-35B is similar in dimensions to the F-35A, however it incorporates several internal changes to facilitate vertical landings. Behind the pilot is a 50-inch diameter lift fan which is connected to the engine by a drive shaft. When in STOVL mode, the lift fan is supplemented by the main engine exhaust which is vectored down, providing 2 main axes of thrust. This system allows for the use of a common, low bypass engine with the other variants. To accommodate these internal changes, several compromises had to be made, including reducing the total internal fuel to 13,500 pounds and reducing the size of the weapons bays. The F-35B has the shortest combat radius of 450 nautical miles and the lowest maneuvering limit of 7 Gs. The final variant is the F-35C, which is optimized for more conventional carrier use. The greatest difference of the C variant is its larger wings, which provide an additional 3-meter wingspan when unfolded, allowing for improved low-speed handling characteristics. The F-35C has a combat radius of 600 nautical miles, but is the heaviest variant and is also limited to 7.5 G. All three versions share the same 40,000 pound rated Pratt & Whitney F-135 engine, the most powerful power plant ever placed on a fighter. They also have the same avionics package. As the F-35 was designed from the outset to be a fifth-generation replacement for the F-16 and FA-18, keeping their strengths as strike fighters while adding new capabilities which define fifth-generation aircraft, also addressing their primary weaknesses as well. Given the F-35 is a low observable or stealthy aircraft, this necessitated some substantial design changes. The first was the requirement to carry weapons internally. The F-35 has a pair of weapons bays which, in the A and C models, are large enough to house 2,000 pound class weapons such as Mark 84 based JDAMs and the Joint Standoff Weapon. The F-35B is limited to the internal carriage of 1,000 pound class weapons. Currently, all variants can fit 4 AIM-120s in the internal weapons bay, but with the Block 4 update, the A and C models will be able to carry 6. The other major design goal was large internal fuel volume. Legacy fighters, such as the F-16, typically carry large external fuel tanks. However, these not only compromise the aircraft's radar cross-section, but they also take up valuable weapons stations. To allow for stealthy operations, the F-35 has a massive internal fuel volume, over twice the amount of the aircraft they replace. In fact, the F-35A has more internal fuel than an F-16 with 3 external drop tanks. Finally, in addition to the internal weapons bays and much greater internal fuel volume, the other major advantage over legacy aircraft is payload. The F-35A can carry over 8 tons of payload over 10 different weapon stations. Operating in non-stealthy beast mode, it can deliver 6 2,000 pound GPS-guided bombs over its internal and external weapon stations, in addition to 4 air-to-air missiles at a range of several hundred nautical miles. This range to payload equation is one of the greatest advantages the F-35 has over the aircraft it replaces. So just how expensive is the F-35? It is perhaps in the area of cost that the greatest level of disinformation exists about the F-35 program. Aircraft costs are often complex and hard to understand. Typically quoted costs will be in then-year dollars that are inflation adjusted and may include elements like spares, parts, training, weapons, and even spare engines. In fact, sometimes through-life cost is quoted, which includes all of the costs of running the airplane, including fuel and wages, for its entire 30-year life. As you can imagine, quoting a through-life cost may have very little to do with how much a plane costs to buy. In this instance, the United States Department of Defense may not have done themselves any favors by completing an internal estimate of the F-35's total through-life cost, which was in excess of $1.7 trillion. Given how outrageous that number sounds in a vacuum, this sent the non-specialist media into a frenzy, generating countless clickbait headlines. However, $1.2 trillion of this total is the cost of operating over 2,000 F-35s until 2077. Parts, spares, fuel, wages, weapons, everything, over a period of some 57 years. These are the kinds of costs that apply to any aircraft. The release of that estimate has had a very negative impact on the quality of the general public's understanding of the F-35 and has only increased the prevalence of disinformation regarding the program. So what are the actual costs? As of December 2019, the projected total procurement costs are as follows. The total research and development budget of the F-35 program, including all 3 variants, is $71.9 billion. The total acquisition cost for 2,470 F-35s, including the test aircraft, is projected to be $245 billion. Finally, the military construction costs, such as upgrading facilities, are projected to be $4.5 billion. All of those totals are inflation adjusted for 2012 US dollars. So, hopefully, that clears up some of the confusion around the total program cost. But how much is an F-35 if you actually want to buy one? The per unit or flyaway cost tends to change with each manufacturing lot as manufacturing costs come down over time. The current contracted costs for Lot 14 aircraft are $77.9 million for an F-35A, $101.3 million for an F-35B, and $94.4 million for the F-35C. Those flyaway prices are, at the very least, competitive with 4th generation aircraft such as the F-15EX, Dassault Rafale, or Eurofighter Typhoon. So what about its aerodynamic and kinematic performance? Is Pierre Spray's infamous line, "can't turn, can't climb, can't run," an accurate description of the F-35? There were early press reports which seemed to indicate that the F-35 had severe trouble in BFM, or Basic Fighter Maneuver, exercises with F-16s. Infamously, the website War is Boring gained access to a test pilot report that claimed that an early test aircraft, AF-2, struggled when engaging with an F-16 in a basic dogfight. The article's author, David Axe, an equally infamous critic of the F-35, used this report to argue that the Lightning's aerodynamic performance was exceedingly poor. However, spending just 5 minutes reading the report itself reveals the dishonesty of this reporting. The F-35 in question was an early test aircraft which was running heavily restricted software. In fact, said restrictive software was the pilot's primary complaint. Clearly, this is not representative of a combat-coded F-35. With Block 3F software, there are reports from Dutch pilots that the only way the F-16 can remain competitive in BFM is if it flies without any external fuel tanks or weapons. It is unfortunately this kind of bad faith reporting which has poisoned the public discussion of the F-35. In terms of maneuverability, the F-35 was designed to take the best features of the F-16 and Hornet and combine them. The Hornet's best asset in a within visual range fight is its high alpha, or angle of attack, capability. Angle of attack refers to the angle of the wing to the oncoming airflow. By allowing the pilot to access these very high angles of attack, the F-35 can quickly pull the nose inside the turn, a key advantage in a within visual range missile fight. Much like the leading edge root extensions on the Super Hornet, the F-35's pronounced intakes act as powerful vortex generators, which produce a low pressure above the wing and increase lift at high alpha regimes. There are reports that, in a high alpha turn, the F-35A can achieve an instantaneous turn rate well in excess of 28 degrees per second, which is very impressive. However, accessing these high angles of attack will tend to rapidly decelerate the aircraft, leading to energy loss. This was a key weakness of the Hornet, as its relatively low thrust engines prevented it from regaining energy quickly. The F-35 is equipped with the most powerful engine ever used in a fighter, and it can, therefore, use that thrust to rapidly redress the energy loss. Depending on the fuel load, the F-35A can accelerate from Mach 0.6 to Mach 1 in the same time as a cleaned F-16, around 17 seconds. As the F-35's performance envelope has been increased with successive software updates, it has become clear that it holds a distinctive maneuvering advantage over both the F-16 and FA-18, especially when combat loaded. So, it can turn, but can it climb? Well, considering it has a thrust-to-weight ratio of better than 1:1 with 50% fuel, it can definitely climb. But how about running? The F-35 is limited to Mach 1.6, which seems to make it quite slow compared to the F-16 and Su-27, which have published top speeds in excess of Mach 2. This seems concerning until we realize that aircraft, basically, never go faster than Mach 1.6 in real combat. For starters, those speeds are only achievable with clean aircraft. But in the entire Vietnam War, not 1 second of combat flight time was recorded at Mach 1.8 or above, even though the primary fighter, the F-4 Phantom, was capable of Mach 2. The same story is true for all recorded combat between 4th generation fighters. This is because it takes a substantial amount of time to build up those kinds of speeds, and not only will they consume gargantuan amounts of fuel, but any maneuvering at all will rapidly decelerate the aircraft. Therefore, it is acceleration rather than top speed which determines a fighter's ability to disengage. And in this instance, the F-35 is certainly competitive with combat-loaded 4th generation fighters. So, in reality, the F-35 can turn, it can climb, and it can run. But the F-35's kinematic performance, as impressive as it is its least important combat capability. What makes the F-35 a true 5th generation fighter, indeed what makes it a killer, is its ability to gain a dominant informational advantage over its enemies. The combination of its stealth, sensors, and sensor fusion allow the F-35 to dominate some of the most respected fighters of the 4th generation. The first element in this deadly trinity is stealth. The F-35 is classified as a low observable aircraft, which means it has a very low radar cross-section, or RCS. RCS is a measure of how large an object looks to a radar. Although specific values for the F-35's RCS have not been published, it has been estimated to be in the range of 0.001 meters squared, about the size of a ball bearing. Stealth is achieved via the application of several techniques. The first is the overall shape of the aircraft. Called Planform Alignment, this involves carefully designing the large radar reflecting surfaces, such as leading edges, to ensure that they reflect radio waves away from the transmitter. Planform alignment was best exemplified by the iconic F-117 Nighthawk. The second major technique is the perfectly manicured minor surfaces, such as weapons bays, landing gear, and maintenance hatches, to break up a radar phenomenon called a surface or creeping wave, where the radar beam is refracted around the surface of the airframe. This requires extremely high manufacturing tolerances, and is one of the primary reasons true stealth aircraft are both expensive and difficult to develop. The third major technique is radar absorbing materials, or RAM, which absorb the microwave energy emitted from the radar. Developing these kinds of materials that are tough enough to be placed on the skin of a strike fighter and don't require excessive maintenance is another huge challenge of designing and manufacturing stealth aircraft. Although the F-35 stealth is best in the X-band, which is the frequency range virtually all fighter radars and surface-to-air illumination radars use, it is still quite stealthy in other frequency ranges and regimes. In general terms, stealth aircraft are less able to defeat long wavelength radars because the wavelength of the radio wave used is large enough that it ignores the aircraft's carefully designed shaping. However, the F-35 still has a very low signature at these lower wavelengths because of the type of RAM used. This material, called a CNT-infused fiber matrix, absorbs radar energy in wavelengths ranging from 0.1 MHz to 60 GHz, with a particular effectiveness in L through K band. Although the F-35 would still have a higher RCS at these frequencies, it would still be far lower than non-stealth fighters. The F-35 also has substantial signature reduction in the infrared spectrum. Under the wings are two air intakes, which direct cool air to the engine. In the F-135's nozzle, this cool air not only reduces the engine's temperature, but is diffused around the engine exhaust plume, substantially reducing its temperature. Given that exhaust plume is the primary source of infrared energy, this technique substantially reduces the F-35's IR signature, as long as it is not operating at very high thrust levels. In combination, these signature reduction techniques substantially reduce the range at which the aircraft can be detected and tracked by microwave or VHF radars and infrared search and track systems. The second element of the F-35's deadly trinity are its sensors. Arguably both the most overlooked and most important element of the F-35's capability is its revolutionary sensor suite. The centerpiece is the AN/APG-81 Active Electronically Scanned Array, or AESA radar. AESA radars use a large number of transmit-receive modules, which each act as a small, miniature radar. Thousands of these modules make up the array as a whole, and they electronically steer the radar beam, providing scan rates which are measured in milliseconds. Because of their increased sensitivity, AESAs are also far more capable in terms of detection and track range compared to legacy systems. The APG-81 is a very large and powerful AESA which is made up of over 1,600 modules, and is capable of operating in multiple modes simultaneously, conducting air search, synthetic aperture radar ground imagery, and offensive jamming modes all at the same time. As this radar can rapidly shift frequencies and form very short pulse lengths, it is very hard to detect by radar warning receivers, a capability called Low Probability of Intercept, or LPI. This allows the F-35 to use its radar with a very low risk that it will be revealing its position. The ASQ-239 Barracuda electronic warfare suite is a broadband electronic intelligence system comparable to the ALQ-218 used in the EA-18G Growler. The system combines a number of antennas on the leading edges of the wings, vertical stabilizers, and rear stabilators, with a dedicated computer system which provides the F-35 with continual 360 degrees of electronic intelligence coverage. It is able to both identify and geolocate transmissions automatically. The Barracuda system is integrated with the APG-81 radar, which acts as the transmitter for offensive electronic warfare techniques such as standoff jamming. Because of the APG-81's high power output and very narrow beam, the F-35 is capable of highly effective jamming, comparable to dedicated systems such as the EA-18G. Under the nose is the Electro-Optical Targeting System, or EOTS, which combines FLIR and IRST technology to act both as an air-to-air and air-to-surface targeting system. It includes a laser rangefinder and a laser spot tracker. EOTS relieves the requirement for a dedicated targeting pod, which maintains the F-35's low RCS. The system provides both very high-resolution TV and IR imagery, allowing for laser and GPS-guided weapon employment, in addition to passive aircraft identification and wide-area infrared search. EOTS is combined with the AN/AAQ-37 Electro-Optical Distributed Aperture System, or EODAS. This system is a complex of 6 imaging infrared sensors which are arrayed around the aircraft to provide the F-35 with 360 degrees of continual IR coverage. EODAS is much more than a typical missile approach warning system, although it fulfills that role. It essentially acts as an infrared search and track system that continually provides the F-35 with spherical coverage, including infrared imagery which can be projected onto the pilot's helmet, allowing them to literally see through the floor. EODAS allows the F-35's onboard computers to continually monitor the airspace around the aircraft, including automatically detecting, tracking, and identifying threats such as other fighters. Combined with high off-boresight missiles which have a lock-on after launch capability, such as the AIM-132 ASRAAM or AIM-9X Block 2, EODAS allows the F-35 to take close-range missile shots at any angle, including at targets directly behind it. The third part of the F-35's trinity of deadly capabilities is something called sensor fusion. This is a hard kind of capability to quantify, as it can't be measured as easily as how stealthy a fighter is. In simple terms, the phrase sensor fusion means the integration of all of the aircraft's sensors into one larger integrated system. So why is this important? Why would I list this as one of the F-35's most lethal capabilities? Shouldn't we be focusing on Cobra maneuvers? Sensor fusion really is at the heart of what makes the F-35 so lethal. Its ability to gain an information advantage over the enemy. In legacy platforms, each different sensor would have its own display system, and it would be up to the pilot to not only manage those sensors, but to take the information these systems provide and form a coherent tactical picture themselves. The F-35 does all this for you. All the pilot interacts with is a single tactical display which shows all of the information the aircraft has access to, either from its sensors or via data link. This is more important than it sounds, as pilots often become task-saturated trying to manage multiple systems in a complex tactical environment, all whilst trying to fly the aircraft. But the benefits of sensor fusion go far beyond reducing the pilot's task load. By integrating the sensors into one single system, they can be used in combination. As all of the sensors have different strengths, they can compensate for each other's weaknesses, allowing for powerful synergistic benefits. For example, if the Barracuda system detects a radar signal which it believes may be a fighter, the APG-81 will automatically scan the target with a small burst of radiation generating a track. Because only a very small radar pulse is required, the F-35 can remain hidden whilst having a firing solution on the enemy. This all occurs before the pilot is even aware of the Barracuda contact. The same thing happens with its infrared systems. If EODAS detects what the computer believes is a missile launch, this will automatically cue other sensors which have a much higher resolution at long range, such as EOTS, allowing for rapid classification and track. This fusion is only enhanced by the F-35's substantial networking capability, through both Link 16 and its dedicated multifunction advanced data link. When combined, the F-35's deadly trinity of stealth, sensors and sensor fusion make the Lightning one of the most lethal air-to-air fighters currently active in the world today. Reports from exercises such as Red Flag show just how devastating the F-35 is. Even though its full capabilities will not be realized until the Block 4 software upgrade, across numerous large-scale exercises it is already racking up a truly impressive kill ratio of 28-1. With relatively new F-35 pilots facing seasoned aggressors flying advanced 4th generation fighters in very large numbers, reports from several encounters show just how devastating the Lightning is. In one anecdote from Red Flag 2019, a flight of F-35s from the 388th Fighter Wing's 4th Fighter Squadron were facing over 60 aggressors in a very challenging, intense electronic warfare environment. One member of the flight was a very new pilot with only 8 hours in the F-35 straight out of training. In that mission, He not only achieved 4 kills, but saved a 3,000-hour veteran in a very advanced 4th generation fighter, shooting down a bandit he didn't even know was in firing position. The flight leader had never seen anything like it. Similar performance was seen in the air-to-ground role, with Italian F-35 pilots destroying over 100 simulated surface-to-air missile sites without a single loss. The F-35's combination of internal weapons, sensors, electronic warfare, and low signature make it uniquely suited to penetrating advanced ground-based air defense systems. The aircraft's stealth drastically reduces the practical radar range of ground-based systems, and the Barracuda electronic warfare suite constantly identifies and geolocates hostile radars, allowing the pilot to plot the safest path to the target. As the APG-81 radar can act as a high-precision jammer, the F-35 will be able to selectively jam the most threatening surface-to-air missile systems, improving its ability to operate in denied environments. The radar's synthetic aperture radar modes allow the F-35 to employ GPS-guided weapons in all weather conditions from standoff range, and EODAS provides the pilot with 360 degrees of infrared imagery, which not only eliminates the need for night vision goggles, but substantially improves its ability to detect targets on the ground. With the Block 4 software package, the F-35 will take on the nuclear strike role with the integration of the B-61 340 kiloton free-fall thermonuclear weapon. The reason the F-35 is able to be so dominant in red flag, even though its Wikipedia statistics will tell you that it's nothing special, is that aerial combat isn't what it was in the 1970s, a point Pierre Sprey seems to have missed. Information dominance allows the F-35 to dominate the battle space, allowing for countless kills of victims who did not even know they were being engaged. Seeing and not being seen means shooting without being shot at, and in the complexity of a real-world tactical environment, this advantage soon becomes overwhelming. Information is the high ground of 5th generation combat, and information dominance is what the F-35 does. Rather than being the failure that many have proclaimed it to be since the program's inception, including the infamous Forbes article in 2021, the F-35 is already the most successful fighter program since the F-16. Not in living memory has a single military platform had so many detractors. And as they keep calling the program a failure, it simply keeps delivering. Over 600 F-35s have already been procured, and with international orders from Australia, the United Kingdom, Israel, South Korea, Belgium, Italy, the Netherlands, Norway, Japan, Denmark, Singapore, and Poland, the Lightning II will be the backbone of Western air forces for decades. As of 2021, the United States military intends to procure over 2,400 aircraft, and total foreign orders could be another 1,000. A troubled past does not mean a troubled future, and the F-35's combination of range, payload, stealth, sensors, sensor fusion, advanced electronic warfare capability, and, yes, even its kinematic and maneuver performance, make it one of the most lethal fighters in the world. Rather than Pierre Sprey's turkey, the F-35 is an eagle owl, silently stalking the night, bringing death to its unwary prey. People will certainly continue to misunderstand it, and in fact some may continue to smear it, but the F-35 will simply continue adding capabilities and racking up the successes. After all, reality doesn't really care what the fighter mafia thinks.